Hello all. This is a short video that I made to help you write the statistical analysis section of your grant. I'm not expecting that you're going to write much about that, but at least a paragraph I'm expecting, and I'm hoping that this video will help you with that piece of it. So what I would like to do is to kind of go through four major topics. I wanted to talk about types of variables that you can measure in a study, the levels of measurement of these variables, the frequency distributions of these variables, and these you understand why we need to talk about these, because it's important to know some of these before you can pick the correct statistical test for your project. And then finally, we're going to talk about the specifics of choosing a statistical test. So let's start with types of variables. We have two major types of variables: quantitative variables, and these are variables that can be measured on an independent scale with units. So everything that you have a unit for is a quantitative variable. And examples can be weight, height, blood cholesterol. These are all measured in a scale, and they have units. Weight is in kilograms or in pounds. Height can be in inches, in meters. Blood cholesterol usually is in milligrams per deciliter, and so forth. Then we have qualitative variables. These cannot be measured on an independent scale, and they can also be called categorical. And some examples are gender, blood type, level of education. Next, we have levels of measurement. So it kind of relates to the types of variables. So quantitative variables are those that are measured in a scale, or they can also be called continuous data. And qualitative variables can also be called categorical variables. They can be categorized into two different types. We have ordinal data, and these are data that are ranked. And an example would be when you're measuring something in a Likert scale. Let's say you're asking people to taste something, and you ask them to mark on a scale of 1 to 5, from 1 being strongly disagree and 5 being strongly agree. So there is an order to this, because the higher numbers are the ones that represent greater agreement. So that's ordinal data. But you also have nominal data, which are data that are categorical but not necessarily ordered or ranked. So an example would be level of education, right? Because you would have high school, some college, professional degree, and etc. Moving on to frequency distributions. A frequency distribution of a variable is either a table or a graph that shows the profile of the frequencies. So by frequencies here, I mean the number of people who have specific values that fall across the entire range of variation. So let's give a concrete example here. If you have blood cholesterol and your data range from 110 milligrams per deciliter to 450. So a distribution, a frequency distribution, will tell you how many people fall within each value of cholesterol between 110 and 450. The most common type of graph is used to depict a distribution is a histogram, and I'm sure you're familiar with histograms. So here I'm showing you some common distribution shapes. The top one is what we call a normal distribution. And then you have some other types of distributions. You have a bimodal distribution, a unitary distribution, a negatively skewed, or a positively skewed distribution. There are some statistical tests that have assumptions about the data that need to be met. And one of the assumptions could be, for example, that the data are normally distributed, which would be that top graph there. And as a matter of fact, the t-test has that assumption that the data are normally distributed. So you need to first check your data that it is indeed normally distributed before you can use that t-test. So now let's move on to choosing a statistical test. There is first a few things that you need to know about your data before you can choose, right? So the first thing that I would like to go through is, what are you really interested in knowing about your data? So in other words, what question are you trying to answer? And I have here 3 different types of questions that may come up, and they may be more common for us to try to answer in nutrition related studies. So the first one could be, is there a difference between intervention groups? That's a big one, right? When you're trying to test an intervention and you have several groups or only 2, you want to know, is there a difference, right? Is my intervention working compared to a control? Another one may be, are the variables associated? And the third one could be, can an outcome be predicted from other variables? And these other variables may also be called predictors in this case. So now let's go through each one of these questions and see how we may use a statistical test to try to answer them. So let's start with, is there a difference between groups? So first you got to determine how many groups you're comparing. If you're comparing more than 2 groups, the correct test to use is analysis of variance, or ANOVA. So you can just say in your statistical section that you're comparing the changes in the groups using analysis of variance, and that should be pretty simple. Now, if you are comparing 2 different groups, then now we need to figure out what types of samples do you have. You need to determine whether your samples are independent or related. If your samples are related, then you got to determine whether your data are on a scale or if they're categorical. Okay, so if your data are measured on a scale, then the parity test is used if your data are normally distributed. If your data are not normally distributed, but they're still continuous data, then the test that we use is a non-parametric Wilcoxon test or a sign test, depending on additional characteristics of your sample. So the Wilcoxon test assumes that the distributions in your control and in your intervention group are equal, whereas the sign test does not have that assumption. So it's a little more flexible. So now you have to go and look at the distribution of your variable of interest. So let's keep that cholesterol example. So if you're looking at blood cholesterol, but the distribution of blood cholesterol in your control group is different than the distribution in your intervention group, then the sign test is the one to be used, because it does not assume that those distributions are equal. And still, the Wilcoxon and sign test you will use when you have non-parametric data, which means that they're not normally distributed. Now, if your samples are related and your data are nominal, so we talked about continuous data. Now, if your data are nominal, there's only one test here that I'm going to tell you about, which is the McNamara test. Okay, so in this case, it's pretty simple. Now, let's move on. How about if your samples are independent? Okay, so now it's not, if your data are continuous, then you're not using a paired t-test because they're not related. So if the samples are independent, you just use an independent t-test. So you have 2 types of t-tests. The paired t-test when the data are related, when the samples are related, that is, and the independent t-test when your data are independent. And again, this is for normally distributed data. When you have non-normally distributed data, you use a non-parametric Mann-Whitney test. If your data are nominal or categorical, then there is a test called the chi-square test of association that can be used. Okay? So let's move on from this question and get to the next one. Are the variables associated? If your data are measured on a scale, so if you have continuous data, both, let's say you're trying to see if there's association between cholesterol levels and saturated fat intake, then both of those are measured on a scale, so then you can use Pearson correlation coefficient. If your data are ordinal, so you're measuring, let's say you're just asking specific questions about liking something, and you want to know if the fact that people like less or more one thing is associated with another variable, then the correct test to use is the Spearman rank correlation. So it really depends if you have scale data or ordinal data. Okay. Now, if your data are nominal and you have two variables, you can use a chi-square test for association, or you can use a phi coefficient Kramer's V. I know that's a lot of words here, but again, you don't need to understand a lot. You just need to figure out what type of data you have, and you just pick this test. You just say that you're going to be doing this test, okay? Now, if you have more than two variables, then it's a log linear analysis that we use, okay? And that's just as simple as that. And finally, we have our third question: can an outcome be predicted from other variables? So if your outcome of interest is qualitative or categorical, you can either do a discriminant analysis or a logistic regression. Okay, a logistic regression is very common. So logistic regression, for example, can be used when your outcome of interest is disease, let's say having had a stroke or not. So it's a yes or no. Did you have a stroke in the past 10 years? Yes or no. So that's your outcome of interest. Only two answers, yes or no. You can use a logistic regression. So if you have an outcome in your proposal that is like that, you can say that you're going to use a logistic regression. Now, if your outcome is quantitative, then it depends on how many variables we're talking about. If we're talking only about two variables, you can use a bivariate regression, or it can just be called a linear regression. Or if you have more than two variables, then we can say that you're using a multiple linear regression. Okay, so I forgot to actually add the word linear here, because these are all linear regression to distinguish them from logistic regression that is used for categorical data. Okay, so for quantitative data or continuous data, we use linear regression, and it can be bivariate linear regression or multiple or multivariate linear regression. And finally, my last slide here is to give you some examples of how you would, word that section, the statistical analysis section. So I took actually these examples from articles that I have published in the past. So one of them could be: baseline comparisons between controls and exercisers will be made using students' t-test for continuous variables and chi-square for categorical variables. Another one could be: associations between the changes in inflammatory markers and changes in percent body fat and fitness will be examined using Pearson correlation coefficients. So this is just so you guys have an example of how you would write this in your grant. And finally, changes in inflammatory markers between groups will be assessed by analysis of variance. So I'm hoping that this will really help you guys get through the statistical section of your grant proposal. It does not have to be big, just like one short paragraph should suffice. Okay, and then I'll be here also to answer any questions that you guys have, and you can send me your draft and I can provide comments on it. The only other thing that I didn't put in this slide that I should probably mention is that in addition to saying in your statistical analysis section, in addition of saying which tests you're going to be used, a lot of times if you look at any paper, people will end by saying that they were using statistical significance level at p lower than 0.05, just to show that if anything had a p less than 0.05, they consider that significant. And they usually also say what type of software they're going to use to do the statistical analysis. I use SAS in my studies, but SPSS is actually another software that is much more intuitive and much easier to use. So you can also say something like that. You can look in other papers just to see what people have said, but I would say that SPSS will be used, and sometimes people will even put the version of it that will be used.